So how do you properly measure your DevSecOps maturity? Let's take a look at something called the DORA metrics. It's obviously essential to continuously aim to improve and grow when it comes to your DevSecOps maturity, but how do you measure the work effectively so that metrics don't become the actual impediment? I've seen it again and again. People measuring the wrong things. At some point, the DoD was measuring the number of lines of code being produced as if it was the right thing to measure. And of course, companies were then paid more money to write more code and make the code more complex, creating more bugs and problems. That's a good example of a metric you probably don't want to take a look at. So the DevOps Research and Assessment, otherwise known as DORA team, is a research program that was acquired by Google in 2018. Their goal was to understand the practices and capabilities that enable teams to achieve high performance in software delivery. From 2014 to 2019, the group published their best known studies, a series of annual reports to benchmark DevOps practices and provide guidance for how DevOps teams can continuously improve their processes and capability. In their 2018 book, Accelerate, the DORA team identified a set of metrics which they claim indicate software teams' performance as it pertains to software development and delivery capabilities. DORA metrics are used by DevOps teams to measure their performance and find out whether they're on the low performer side or the elite performers. There are 4 metrics used with deployment frequency, DF, change lead time, LT, mean time to recovery, MTTR, and change failure rate, CFR. Let's take a look at this. So let's begin now with the first DORA metric, deployment frequency. Deployment frequency really means the frequency of successful software releases to production. Don't forget the word successful here, that's very important. We measure how often the team releases to production successfully, indicating how quickly the teams are delivering software and their velocity. High-performing teams aim to ship smaller but more frequent deployments. This has the effect of both improving time to value for end users and decreasing the risk, because the smaller change mean easier fixes when changes cause production failures for the development teams. So as you can see, you have the ability to compare now for low performers, medium performers, high performers, and elite performers. For low performers, you will see deployments between once per month and once every 6 months. For medium performers, you will see deployments once per week and once per month. High performance will be between once per day and once per week, and elite performers will be on demand, multiple deployments per day. Now let's take a look at the second DORA metrics, change lead time. Change lead time means the time between a code change commit and its deployable state. That means the change between the time your developer commit the code in your Git repo and when it is deployable in production. It measures the total time between a change request and its deployment in production. It helps understand how efficient your development process is. Long lead times may be the results of bottlenecks in your DevSecOps pipeline. Comparing the time of first commit of code for a given issue to the time of deployment isn't good enough though. A more comprehensive method would be to compare the time that the user story is selected to the time of its deployment to production. Because often what you're going to find is that teams in the planning phases are wasting a lot of time to start coding. Low performers would take between 1 month to 6 months to go from code commit to production. Medium performers will be between 1 week to 1 month. High performers will be between 1 day to 1 week. And elite performers will be less than a day. Now let's take a look at the third DORA metrics, mean time to recovery. Especially important when it comes to critical mission like the DoD weapons. Mean time to recovery means the time between an interruption due to deployment or system failure and the full recovery in production. Resolving incidents and failure in production is essential. The time from an incident having been triggered to the time that it has been resolved in production, optimizing your mean time to recovery, minimizing your downtime, and over time builds out systems to detect, diagnose, and correct problems when they will occur. This is part also of your chaos engineering. Check out that video and also check out the other segment on service level indicators, service level objectives, and service level agreements, SLAs. So when it comes to low performers, what you're going to find is between 1 week to a month to recover from an incident. And I don't know about you, but I probably wouldn't want to have my service down for a month. That sounds pretty bad. My medium performers will be less than a day. High performers also less than a day. And elite performers will be less than an hour. You can see the direct impact to your SLAs right there. So now let's take a look at the fourth DORA metrics, change failure rate. The change failure rate is how often the team changes lead to failure after deployment. That's really the rate at which production changes result in incidents, rollback, or failures. It tells you kind of the quality of the code that you're pushing to production. The lower the rate here, the better. But the change failure rate should decrease over time because your team is maturing. You must define what a failure is for your organization, though. It must be customized often per team and service. Too broad or too limiting of a definition and you will encourage the wrong behavior. That should probably be tied to your service level indicators and service level objectives. So you're tracking really what a downtime or an incident really is. So for low performers, you're going to find a percentage of changes degrading services between 46 to 60%. Medium performers will be 0 to 15. Same for high performers and elite performers as well. There you have it. Now you understand how to properly measure your team's work and what kind of metrics to pay attention to with deployment frequency, change lead time, mean time to recovery, and change failure rate. Don't make the mistake to start looking at metrics that will push your team to implement the wrong behavior, such as lines of code or simply looking at speed without paying attention to defects and cyber issues. A balance between quality, security, and productivity is essential to become a mature DevSecOps team.